So we remember from the last class that we talked about there are two last new formulas. The electrical power of an electronic device. Okay? And we talked about power as being that last new variable. And there's two different instances that we can use a power equation, or we can use power within an equation. Because power is the amount of work that an actual machine carries out within a certain amount of time. Okay? And power, in terms of the units of it, is measured in watts. Okay? So when we look at light bulbs, we see that they are, 60-watt bulbs. Or the energy efficient ones are 9-watt bulbs. That means that they are using 9 watts of energy within a certain time frame. Okay? That's what that actually means. Now, when we're talking about circuits, well, we don't actually have something that can measure. Well, I'm sure there probably are some machines, but in the case of the circuits that we're going to be building, we don't have, a power reader. But we can calculate the power based on knowing two different variables that we can actually measure in a circuit. We can use ammeters to measure the current intensity, and we can use voltmeters to measure the potential difference. So we can actually find an object's or a machine's power by using that second formula, where the electrical power of the object, that it uses is equal to the current intensity times the potential difference that goes through that actual circuit that runs that actual object. Okay? Now, when we use the first formula, we're going to actually practice using this guy today, because we're going to look at calculating the cost required to run certain objects. Okay? So there's a lot of variables on the board right now. Let's assume that this is a space heater. Okay, one of those little heaters that you plug into the wall and it provides warmth. Okay, radiates, those coils get really, really hot and it radiates warmth. So I'm telling you that heater has a potential difference of 120 volts. It runs with a current intensity of 30 amps. And I'm going to run that sucker for 5 hours a day, 5 days of the week. Okay? Energy costs 0.08 or 8 cents for every kilowatt hour. How much is it going to cost me to operate my heater for 5 hours a day, 5 days of the week? That is what we are going to calculate. Okay? Now, first things first. In order to calculate kilowatt hours or energy, I need both of these formulas. Okay? Because I don't have my E. And I need my E because at the end of the day, the energy formula is going to be energy is equal to, an energy cost, I should say, is going to be equal to the energy used times the rate. And the rate is the amount that Hydro-Quebec charges you. Okay? So there's 3 formulas that we are going to use today. First things first, I need to get a unit here. Okay? I don't have my actual power. So what can I use to solve for power from my givens?
Potential difference times current intensity.
I can use my potential difference and my current intensity. So number 1, I am going to use PE is equal to IB. I don't have to rearrange this one. I just got to plug in my numbers. So working this out, I should get a PE of 3,600 watts. But here's the deal, okay? If I look at my actual givens here, I see that energy is charged in kilowatts, not watts. Energy is charged in kilowatt hours. Well, I've got watts here. So I'm going to have to change the watts to kilowatts. So what we end up doing here is we've got our 3,600 watts. And then there are 1,000 watts in 1 kilowatt, which cancels this out. So basically you're dividing this number of watts that you just calculated by 1,000. Okay? It's going to give us a PE of 3.6 kilowatts. Okay? So we're almost at that kilowatt hour unit. It's really important to note that when we're dealing with an energy cost problem, the unit for time is no longer seconds just for this. It is hours. Just like the unit for power is no longer watts, but kilowatts. And the reason for this is that Hydro-Quebec gives us a rate in kilowatt hours. That's what this kWh stands for. Kilowatt hours. Okay? So we've got a whole chunk of time here. We've got 5 hours per day for 5 days of the week. Well, if we do this, we don't really have to change anything here because we've already got an hour sum. Right? We know that we use 5 hours a day. But how many days do we do that for?
5.
So, exactly. We do that for 5. So, number 2 here is you're going to take your time and you're going to determine how many hours. And we do that by just looking at what we've got. So, we've got 5 hours per day times 5 days. Right? So look at this. The days cancel out and you're left with hours as your unit. That's fantastic. What's 5 times 5? 25. So you're going to be using 25 hours of time here. My heater is running for 25 hours. Is everybody with me?
Yeah.
Now that we have the units that we require for energy, well, we still don't have our energy. We've got the amount of power that we need, or that we're going to use, and we've got the amount of time that we use it for. So which of these equations has power in it and time and also has energy? Which formula? PE equals E over delta T, this guy. Now, just to help you out here, we're going to draw that friendly little triangle that you so love, okay, to find out what we do. We've got our PE here, we've got our E over T, correct? So if I'm trying to find what the energy is there, and I've got to rearrange that equation, I'm going to cover the energy, and I'm left with PE times T. And if you look in your textbook, we look at page 156 in the text, okay? So if we go to page 156, we see that they rearrange that PE equals E over delta T equation. They rearrange it for E. And that equation is simple. It is E is equal to PE times delta T. We have the PE and we have the delta T. So let's look at this. We've got 33.6 kilowatts. And we multiply that by 25 hours. Look at our units. So this gives us 90 for the numbers. But what happens to these units? Can you erase any of these units? Do any of them cancel out? No. When you multiply a kilowatt by an hour, you get kilowatt hours. Well, look at that. Our rate is given to us in kilowatt hours. We now have a kilowatt hour. So this works out. So we're left, okay, so this is number 3 here. We're now left with that final equation. If we look onto the first page, if we want to calculate the cost of the energy, we're going to use energy cost is equal to the energy that we used in kilowatts times, or kilowatt hours, I should say, times the rate that we're charged per kilowatt hour. Okay? So that ends up looking something like this. All right? So we've got cost. This is number 4. Cost is going to be equal to energy times rate. Right? So our energy is 90 kilowatt hours times we'll put a dollar sign here, 0.08 per kilowatt hour. Look at that. Kilowatts hour on the top, kilowatts hour on the bottom. What does that mean? They cancel out and you're left with just your dollar sign, which is what you're looking for. You're left with your cost. So if you multiply 90 by 0.08, you will get a numerical value. So it comes up to $7.20. So it's going to cost me $7.20 of my power bill will be because I operated that actual heater, okay, for 5 hours a day for 5 days of the week. That's how you solve one of these problems. So to break down the calculation of an energy cost problem, first things first, now sometimes you won't have to find PE. It might be given to you. Example number 11 on the worksheet already has PE given to you. Okay, you didn't have to calculate it. But you may have to calculate it. And if you do, you're going to multiply the current intensity by the voltage, the potential difference. Number 2, you're going to transform your watts, your PE watts, into kilowatts by dividing that number by 1,000. Number 3, so that's number 3. Number 4, you're going to find your time in hours, not in seconds. Then you are going to input the power in kilowatts times the time in hours to get the amount of energy in kilowatt hours. And then finally, you're going to use the cost equation, which is the cost of that appliance being used is going to be equal to that energy that you just calculated times the rate that you will be given. And your units there should be dollar signs because that is what a cost is.